fairly briefly, not the guts of a code interview question, but we will talk about how to do a code question, because that's a little bit of a skill on all of its own. Okay, and then at the end, I assume there will probably be 3 or 4 people who want to do follow-up questions, and so I will stay here until either you're done or I'm exhausted, whichever happens first. All right? Any question is in bounds. You are more than welcome to ask any question you like. There are a few classes of question I cannot or will not answer, and that relates to, well, you ask the question and I'll say I have no comment, or I'll refer you to a public relations document from Google. All right? And I will tell you anything you want to know. I will tell you what color my cat is. Anything. Not one smartass in the room. Usually that cat teaser gets at least one person to say what color is your cat.
Oh, you said you don't have a cat. So.
Fantastic. Somebody read the blurb. I don't have a cat. And so I used to do a ton of tours, and I like doing high school students because they know enough to ask good questions, and I like junior high kids because they will ask anything. And so you kind of throw out the what color is my cat question so that you can identify the one person in the group who needs a little more attention, and you go, okay, you're the troublemaker. Good to know. I don't have a cat. From time to time I have partial custody of a cat. My friend is going out of town to Europe for like a week and a half, and so she's probably going to bring her cat over, and it's a very lovely calico cat.
I have a question. Do you work on Google Campus?
No. When we were first allowed back, I showed up for the first day. There was this. I work in a building that is sort of a big open space, just like the lab out here. 4 people. Second day, 12 people. Third day, 4 people. And I got home and I said to myself, why did I drive in again exactly? Because the best part was I work in a building where there actually is a cafe. It's just all salads. And some other team apparently had decided Wednesday's the day. We're all going to show up on Wednesday and get together and see each other. And they all came to our cafe. And so despite the fact that there was nobody in the building, the line was like half an hour long because all these people had showed up and the cafe was understaffed because they figured nobody was going to be there. Mm-hmm. And like, okay, so, A, there's nobody here to talk to. B, the line is long. There were only about half the snacks there usually are. You can ask me about the snacks. You can ask me about Google entitlement. Entitlement is such a thing. Googlers are such overprivileged people. There are stories about that. And yeah, I haven't been back since.
Got it. Any other questions?
Can you tell us about careers that does not involve technical aspects of computer science, like dating and algebra?
Yep. Yeah, so the question is, I don't have to repeat it back. Well, I'll repeat it back for the benefit of the recording. So the question is, what can I tell you about careers that isn't technical aspects of careers?
Yes, like coding and
So not about the coding?
Yeah.
Okay. So yeah, I can. The main difference is the culture of the company. Startups are fantastic and they're horrible at the same time. Startups are wonderful because they don't have enough money, they don't have enough time, they don't have enough people, and any decision you make that's any more important than what brand of coffee should we put in the break room can make or break the company. Okay. They're running on a shoestring. They are constantly within 12 months of running out of money. And the idea is you build some stuff and then you go to some capitalists and you say, here, look at what we have built. Isn't this wonderful? Wouldn't you like to invest in us? And they say yes or no, right? And then you build some more stuff. And then, 6 to 9 to maybe 12 months later, you say, look what else we've built, and we have some customers, give us some more money, right? And so the company is always on the verge of bankruptcy. And so the wonderful part of that is they will pay you, not a lot, but they will pay you some money, enough to live on, and they will pay you a lot of stock, pay no attention to the stock, and I'll tell you why in a second. But what they will do is, here it is, it's Thursday afternoon, and the production site is down from the last time, and that person isn't going to deal with it because they're burned out from the time before. Who is not urgently involved in some? You, the new person. fix it. They will give you work to do that you have no business doing, right? But there's nobody else to do it. And so the upshot is they will pay you to give you a world-class education in site maintenance, site operations, design considerations. I mean, when all you know is the site is down, is the web server not serving? Is the database full? Is the disk on the backup server full and so nobody else can do anything because the backups are failing? I don't know, okay? And you take that skill set to the next employer and they say, we do XYZ. What do you know about XYZ? And you say, I have no idea what XYZ is, but I guarantee you within 6 hours, I can become an expert enough to troubleshoot your system, okay? So yeah, now it's a real hard life, right? You have to intentionally sign up for 60-hour weeks, week after week after week after week. Startups don't hire people that won't do that because everybody is eyes on the prize of get the company to the point where it's making enough money that you can have a liquidity event and you can trade in these worthless stock options on actual money. 80 to 90% of the time that doesn't happen, right? Almost all startups fail. 50% of startups just hit the wall and pa-chunk, right? Some turn into some amount of intellectual property that can be sold to the next company, but nobody works there. Another small fraction turns into a small company that serves a very niche need and will employ 20 to 50 people for the indefinite future, right? A few of them turn into large to medium companies, 100 to 1,000 people, and a tiny, tiny, tiny fraction turn into big companies. And so you're looking at, am I going to get nothing? Am I going to get enough money to put a down payment on a car, to buy a car? These days I can't even say enough money to put a down payment on a house, right? The brass ring goal at this point is not I have house money, but down payment on a house money. And you know, if you're in the tiny, tiny, tiny proportion of people who was lucky enough to work at, you know, Google or Yahoo or all the companies you could name, sure, now maybe you've got retirement money. But that's exactly the same as getting a basketball out and saying, okay, you know, if I practice 15 minutes a day, I can get into the NBA. Unlikely, okay? So your other option is working at a big company. Big companies are very stable. The work week tends to look a lot like 40 hours. You can have a home life. But a big company already knows how to make money. They are not about taking risks. And so they will take you and they will put you in a spot and they will say, take the thing out of here, you know, turn this crank 5 times and stir it 8 times counterclockwise and put it over there. And you take that and you go to the next company and they say, we do XYZ. What do you know about XYZ? And you say, I know nothing about XYZ. But I know how to turn cranks and I know how to stir counterclockwise. Less valuable, okay? You pay your money and you take your choice. My usual advice is, most of you, without looking too closely, are probably in your early to mid-20s, which means you have a lot of energy, you have a lot of optimism, and you have a lot of stamina. My advice is, if you can possibly do it, get a job at Google. Yay, right? I'm not going to say get a job at Facebook. My personal opinion, so none of anything I am saying is Google's opinion. All of this is my opinion. Do not take any of this as Google thinks. I wouldn't work for Facebook on a bet. Many, many, many problems with self-reinforcing bad social behavior. But if you can get a job with one of the bigs, get a job with one of the bigs. Even if you hate it, the fact that you could get a job with one of the big corps is a fantastic notch on your resume when or if you decide you want to go somewhere else. You can say, Google was willing to hire me, I'm pretty good, okay? If you can't, go work at a startup. You're only gonna work at a startup for, on average, about 18 months. That was my average, right? The average, anywhere between 6 months and 24 months, the company, you know, fell over, died, and laid everybody off. And the only thing I can say is I was always in the last set of people laid off when the company gave up, right? And I spent 13 years doing that. And I never got the brass ring, as you can tell, because I'm still working. Okay. But if you have the energy and the stamina, you can trade energy, stamina, and optimism in on a whole lot of knowledge. And then when you hit your early to mid-30s, you can say, okay, I do need to ease up, I do want to start a family, and now you can start thinking, should I go into consulting? And if you're good at people, consulting is maybe for you. Consulting is a good way to turn deep expertise in a narrow area into a load of money. But it's a lot of word of mouth, right? If you can find an industry that's fairly small, and you can get this person to recommend you to that person, to recommend you to that person, to the next person, it's a whole lot easier than having to cold call every single job. And so your ability to network people, to go out to lunch with them, to go out to golf with them or whatever they like, is part of your ability to get the next job, in addition to being good. Okay, your other option is to check into a big company and crank out your 9 to 5 and admit that you're going to fall behind the curve. Or you can try continuing to run to stay in place. And some people can do it and some people can't. I couldn't. Very long answer, but that's my career advice. If nobody asks me a question, I will tell you amusing anecdotes until you are sick of them.
I have one lead up on the startup thing. So when you choose work for a startup, and you obviously want to choose a startup that's gonna blow up and be successful,
Right.
Is there any like set of rules that you can follow, kind of see are they going to be successful or not? Like, is like owner a smart guy, or like do they like have beautiful technology?
Right, okay. So the question is, if you are thinking about working for startups, how can you pick a winner? And the answer is, if you could pick a winner, then what you should do is not be working in software. What you should do is go to an investment, go to the investment firms and say, I know how to pick winners, and I can prove it. I have picked, blah, 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 blah. People with enough money to float yachts, the way they do it is they get 100 companies and they invest, $10 million in 100 companies, and $1 billion down the drain, on the bet that 1 or 2 of those companies turn into billion-dollar companies and 98 or 99 of them don't. Right? And that's the only way to bet is statistically. Okay, well, how the hell do you do it? Because you can't bet on working for 100 companies. You have to bet on working for 1. And the only thing I can say is 2 things. One, after you have worked for 2 or 3 startups, you get a real good sense when things are not going so well and when it's time to start polishing your resume and looking for the door. You have to have worked at a few startups before you can recognize the signs. The other thing you can do is you can just do a quick sanity check. If the people who are interviewing you are not doing well, if they're asking you questions, so we'll talk about this in the interview portion. If they're bad at asking you questions, or if the questions they're asking tend to indicate that it's a trick question, if they ask you a question with an aha answer, that's a bad interviewer. And now you know that the other people that you'll be working with happened to know the answer to trick questions rather than we're actually good. Okay? The people that are interviewing you will tell you what they want you to do. And if they're asking you, how do I dig out of a really bad situation? They're not going to say, how do I dig out of a really bad situation? But if the questions they're asking amount to, how do I dig out of this really awful, database corruption thing? You can say, I can see by the dark rings under your eyes that this is not the kind of company that's going to be only 60 hours a week, is it? Right? And the other one is you can just sort of look at at what the company is doing and go, yeah, no, nobody wants this. Now you might be wrong, but every once in a while, not once I got to Google, but every year or so, I would just go out on interviews for the sake of going on interviews, not because I wanted the next job, but because I kind of wanted to take the temperature of what was out there. I wanted to keep my interviewing skills up. There was one place that was a startup, and they wanted to do this thing where, oh, I heard this song on the radio, I don't remember what the song is, I want to recover the name of the song, right? And these days you can just hold your phone out and Apple will tell you what that song is within seconds.
Mhm.
Well, this was the bad old days, and they didn't have the technology, and they didn't have enough compute horsepower to do it. And so literally, they wanted you to hum the song into your phone. And and there's the founder of the company, and he's like, try it. And the easy song is Happy Birthday. Everybody knows Happy Birthday, and everybody sings Happy Birthday a couple of times a year. And I couldn't do it. I was embarrassed. I'm like, okay, if I can't do it when a job is on the line, there's no way this company has legs. And I went through the rest of the day and I practiced my interviewing skills, and then I said thank you and goodbye.
Got it.
That's all. That's about all you can do.
What's the difference between working on a smaller project versus a larger project,
Mhm.
and how do you expand on a smaller idea and add features and things without making it a mess?
Okay, so the question is, what's the difference between working on a small project and a large project, and how do you go from small project to large project without becoming a disaster? So first things first, let me clarify the question. What do you mean by small project, and what do you mean by large project?
I think as a student, we only have experience working on projects with maybe a couple files maximum and very few dependencies and things like that. And maybe we take libraries from online resources, things like that. What's the difference between that versus something like Google, where you might have independent company libraries or maintaining
Okay.
something on a larger scale, I guess?
Okay, and so let me, so for the recording, the question is, how do you go from school-sized projects where you're working with a few files and a few libraries and one person to working on larger things? Okay, so here's the deal. Humans are only so smart, and they're only so capable of interacting with other humans. The capabilities vary a little, but by and large, there's a limit to how much one person can produce. But if there's only one person working on it, you can have total control, and you have all of the context of the entire project in your head. And you can go code. Oh, that's going to have a very subtle effect on this part of this display page over here, even though I'm over here in the back end. Okay, and so up to a certain point, one person is the way to go. After that, the next size up is 6 to 7 people. You can have one-person projects. That's its own thing. The moment you start having two-person projects, now part of your job is coordinating with everybody else to make sure that all the cats are kind of headed in the same direction. Okay, and so you're going to lose anywhere from 10 to 25% of your entire productive work life making sure that everybody is going in the same direction. Because if you don't, and you all get 100% productive and you go like this, well then 100% of it is lost, whichever one you pick for, right? And so part of the job is, there are people, program managers or project managers, or there are various names for the role, to go around and make sure that everybody is doing their stuff, that nobody else is blocked. If somebody's waiting on your stuff, maybe it would be better to have 2 people work on it to get it done faster, even though that's less efficient, right? This comes down to the problem of how many people can dig the same hole at the same time, right? One person can dig a hole with no conflicts. 2 people can dig the same hole. It's not great, and you have to be very careful to coordinate, but 2 people can dig the same hole. 3 people can dig the same hole, but it's hideously inefficient, right? You have to be super duper careful to completely synchronize everybody doing their stuff, but you can get done slightly faster with 3 people. And if it's critical, then sometimes you waste 3 people on getting this done 1.5 times as fast. Okay, but the magic limit is somewhere around 6 or 7 people, and that's because 6 or 7 people can sit around a table in a room or in a meeting, and everybody gets to have their say. Everybody gets to feel that they've been heard, and everybody gets to have their concerns addressed. And you can resolve almost all the personality wackinesses inside an hour. Anything over 7 people, 8 especially, is a committee, right? 8 people turns into two sets of 4 people that think something different. And now there's tension, and now part of what you have to do with your life is manage intergroup tension. And so as groups get larger and larger and larger, what you tend to do is cluster people into work groups of 6 or 7, right? And this work group works on one thing, and then that work group works on another thing, and it tends to be the case that this work group works on the same stuff, and then you have to design an API between this stuff and that stuff, back end, front end, something like that. You know, accounting, receiving input from the outside world and deciding what ads have been shown, logging. Taking what ads have been shown and turning that into invoices to the customer, billing, right? And so it is very much the truth that the structure of the software tends to mirror the structure of the organization, because people are only so smart and they're only so capable of communicating with each other. So mechanically, how does that work? Don't worry about it too much. When you transition out of college and into your first work environment, they'll give you some projects, they'll give you some easy stuff, they'll give you some bugs to fix, and it will be within one work group. At Google, we have several levels of software engineer, but the lowest we hire at is an L3, and the number is completely arbitrary, it doesn't mean anything. But a 3, I expect to do, if I had a 3 on my team, I would expect to do a daily or an every other day check-in to see how they were doing, what they were working on, and where they were stuck. I would give them about a week. I would give them a project that I would expect them to take about a week. And at the end of that week, I would check in and say, you know, how are you doing? Are you ahead? Are you behind? Do you need help? And everything that 3 does is within the team. It's code that this team would own. They're not going to need to ask anybody outside the team for any help. All the code is known, all the tests are known, very circumscribed. The next level up is, it's all gonna, the work will all be done within this team's code, but you might have to ask some other team for help, or you might have to ask some other team to add a feature. I would check in with that person about once a week, maybe a little bit more often, maybe a little bit less often, and I'd give that person something that took about a month. The next level up is exactly the same deal, except a lot more outreach to other teams. That person is going to be a lot more proactive about everything, and the scope of work is about a quarter. That's where I am. The next level up is a big step up. You're not doing any coding anymore. You're just doing management and coordination. So slightly long answer, but that's the things other than coding as you step up from college to the various levels. One from this half of the room? Close enough.
Yeah, so in case you actually want to open a startup,
Yep.
you of course have an idea, you have some kind of product that you're going to present and implement, but how do you choose the team members? How do you choose the team that will help you with this so that the startup will not fall down in the 18 months?
Oh.
Yeah.
Okay, so 2 things. Don't take any of this very seriously. I'm going to be brief. I've never started a startup. I've only ever joined startups that were at over 50 people. Under 100, but over 50. I do know the spouse of a friend does do startups, has tried a few startups, and the number one thing that you have to understand about startups is it will eat your life. If you start a startup, either the startup is priority 1 and your family is priority 2, or don't bother playing. It is hard on family. Your family has to have been bought into the idea that they come second. Eek, right? How do you find people? Ideally, you start the startup with a group of friends. that you already all know. The problem is, like I said, startups are always teetering on the brink of collapse no matter what. And so you can have a rock star engineering team and sales team and management team. And if marketing is weak, chunk, right? And the same for any other team. Everybody has to be excellent. If anybody isn't excellent, you have to be willing to let them go at the drop of a hat. That's not so bad though, because if they say, no, but you can't fire me, I'll sue. You go, okay, well look, I have $37. And if $37 is not going to cover your pain and suffering, you can sue us for all the money we don't have. Right? So it is real easy to get rid of people at a startup that aren't performing. Normally, if somebody can't keep up, it's real obvious, and they will self-select out anyway. The moment it's beyond friends, yeah, it's hard. Interviewing is crazy hard. How are we doing that time? Okay. So interviewing is stupid hard. You get 45 minutes to an hour with someone to find out if you are willing to enter into a relationship that will ideally last for years. Right? It is speed dating on steroids. Right? And so I don't have a good answer. I will anecdote this. I had two friends at PayPal that wanted to bail out and do a startup for fantasy sports leagues when fantasy sports leagues were just starting to become a thing. And they're like, how bad could it be? We'll take 6 months off. We have, they both had plenty of money to take 6 months off. We'll start this thing, and if it doesn't pan out in 6 months, we'll go get a job again. No, that's not the worst case scenario. The worst case scenario is in 6 months, you've got it up, you've got 1,000 customers, they're all paying you $1 a month or $2 a month or $5 a month, but not enough to live on. But if you took out a loan against all your credit cards and anything your parents or your friends were willing to give you, you could just barely afford to hire a marketing person. And now, are you willing to, you've got something, it's not completely wrong, it's just you don't have a lot of users. What you need is a lot more users. How do you get a lot more users? Well, you advertise and you market. How much are you willing to spend on that? And are you willing to play, I have a 10% chance of making all this money back, and if I don't make all this money back, I have a really hard time explaining to my friends where their money went. That's the worst case scenario, right? Because do you or don't you? Because the gold ring is right there. Do you dare?
I think one more question.
Oh, hi Ray, on this side.
Yeah, so on that note, so I was just wondering how's the culture and structure at Google is like. So because it's kind of like I have this idea you spend for example next 5 years Google, for example, and you work on these projects, and so how does it work if you want to advance, are you going to go once you deliver good enough, you're going to come into mentoring positions, or for example I'm super passionate about the work with Google,
Let me summarize and check me if I'm a little off, because I'm not sure I'm on. So what is the culture at Google with respect to advancing in responsibility at Google, or is the question what is the culture at Google as far as just working with other people like?
So both. So how could I advance my career at Google, and if I have a chance to start my own projects at Google.
Right. Okay. The culture at Google is, I would say, still better than any other company I've ever worked at. It's not a startup, and so nobody's looking for you to kill yourself. Startups are implicitly saying you are willing to trade in your stamina, your endurance, your enthusiasm, and all your free time on let's make a lot of money. Let's all make a lot of money. And in 5 years, when we're all exhausted, either we've won or we haven't. But let's try. Google has enough money to give literally every full-time employee $1 million out of their cash reserves. If Larry and Sergey aimed the company at the ground and tried to kill it, it would take 5 years. Okay? And so nobody's gonna ask you to show up more than 40 hours a week. However, if you show up 40 hours a week, you probably should expect that your career advancement will be equally leisurely. Okay? Google is not out to ask you to kill yourself. If you want to work harder, if you want to work at a startup pace, yeah, you can tick through the career ladder a lot faster. You know, that comes with all the benefits and all the hazards, right? Now, if you're working up here, you're going to have to stay working up here, or they're going to ask you to find someplace else to be. How long do you want to sustain working up here? I'm where I am, and I've been where I am for 10 years, and I'm real happy. I would actively fight against getting promoted up to the next level. It comes with responsibilities that I don't want, skills that I don't want to acquire, That's not saying that's the right answer for everybody, but that is the right answer for me. It's extremely respectful. If you have an idea or something along the lines of, you know, that seems funny because you'll be listened to, even if you're an L3. Nobody's going to say, no, you're just an L3. Go away. It doesn't happen. Right? Once in a great while, they'll run into somebody who's very proud of what level they've got promoted to. I'm an L7. Okay. Let them be proud. There's nothing wrong with being proud, as long as they're not, I'm an L7 and you're a mere L3. Right? Nobody does that. As far as running your own project, the moment you're an L6, the definition of an L6 is somebody who's good enough to run your own project. The way you get promoted from level to level is you start doing work at the next level up. And once you've obviously been performing at the next level up for 6 months to a year, then it's, you know, everybody says, oh, wait, this person is not already an L whatever? Well, for heaven's sake, you know, promote the person. Obviously, you know, they're doing the work, recognize it. And so you can't say, please promote me, and then work up to it, right? You work up to it and then get recognized.
Yeah, so on that note, so for example, like, do I have a chance like to work with like people from different departments also, like, and
Right.
like if I want like to switch the department in the future by any chance, like, is that possible? Is that okay?
Right, okay, and so the question is, how do I get to a point where I work with people in different departments or different areas of the company? And the answer is you get up to be an L5 or an L6, and it automatically happens. There's very few things at Google that are self-contained. Almost everything, you know, relies on lower level stuff, and almost everything can provide useful input to stuff at a more abstract layer. If you really want to do that kind of thing, Google has an internal program for people that want to do a startup but don't want to do a startup. Okay. And so it's a startup incubator, and so you say, you know, here's my write-up, and so you basically do a business plan. And it's the exact same business plan that you would do for your initial round of investment, right? You work on some project, you take your 20% time, and you build enough of a proof of concept that it's obviously not going to be dumb, right? And then you go do a pitch, just like you would do a pitch to get funding, and then Google says, yeah, okay, great. You are allowed to pick, 4 to 6 other people, and you and the 4 to 6 other people can stop doing their day job for up to a year. Go over here, work on your thing. In a year, we'll evaluate. Just like your second round of funding. Have you done enough to be worth a second round of funding? Yes, keep going. No, go back to your day job. Okay. Now, if it takes off, you continue to get your salary. You don't get $1 bajillion. Risk reward. Right? But you are in charge of your entire own project. You do get to do whatever the hell you want to do in a very startup-y kind of way. And it is just as educational as starting your own startup, but it does not come with the family comes second. It also does not come with the mountain of compensation if you win. Your call. Okay, so that's about a half an hour, a little over. So now I want to change into doing talking about the interview question. suppose it's a nice, easy talk about it question. It doesn't require huge amounts of coding. It doesn't require diagrams. You can almost do this one over the phone, okay? So we're gonna imagine a world where we've got a bag of marbles, okay? And marbles have colors, but any marble with any given color is identical to another marble with the same color. Okay, so we're gonna have this bag, we're gonna put in some marbles, we're gonna write software to emulate the idea of the act of, we've got this bag, you go shake, 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 you reach in, you grab a marble, and you report what color. I got a green one. Green one again. Blue one. Okay? So we're gonna have two functions. There's gonna be an init function. I'm gonna call this init function, and I'm gonna tell you whatever you want about what colors are going into the bag and how many marbles with whatever color it is. You are allowed to take as much time as you want to think about that, to parse it, to understand it, and to turn it into data structures. Because the next thing I'm going to do is I'm going to have a function called pickMarble. I'm going to call pickMarble. It takes no parameters. You can assume a random number generator that does anything you want instantly. And all we're going to do is pickMarble returns a color. Clear so far? Questions about that? Please, if you don't understand, somebody else doesn't understand, yeah.
After selecting a marble, do you
Don't. There's a trap there, okay. He's seen the trap coming. I don't want to show the trap yet. But good. Yeah.
What did the init function exactly do again?
The init function, so I'm going to pass in parameters, whatever you like, to tell you, here's exactly how many of what color is going into the bag at the beginning of time. Right, so after init has been called, the marbles are in the bag is sealed. I will not change what's in the bag, except by possibly calling pickMarble, okay? So we're gonna start the question with the easy half, which is I promise that there will not be more than 10 different colors in the bag, and I promise that for any given color, there will not be more than 10 marbles going into the bag. Talk to me about what data structure you would use to represent this, and what the big O is for space, and what the big O is for speed. Okay, there are some traps here. It is totally fine and expected that you are going to fall into the trap. I have set a trap on purpose, and in the real interview, I will tell you, I have set a trap here, and it is cool if you fall in the trap. What I'm interested in is not that you fall in the trap. Of course you fall in the trap. I set a trap. You're supposed to. What I want to do is find out how able are you to recognize, oh, this is I have fallen in a hole. I'm also interested in, having fallen in a hole, how would I dig out? Because that's what the job is, right? Every single day you write software, every single day you go, oh my God, I have a bug, I'm a moron, oh, it was a typo, right? This 30 years in, it happens to me every single day. Or, oh my God, I'm in a hole, I have a design problem. And can you tell the difference? Okay, the other part of asking questions like this is, I have intentionally given you about 80% of what you need to solve the problem. I have given you 100% of what you should need, if you're clever, to work out what that other 20% is, or to work out, like that question, you haven't told me something very important. Which way is it? Okay, so to get things going, let's come back to you and ask what you wanted to ask.
When you take out a marble, do you put it back into the bag before drawing the next marble, or does it remain removed?
Yeah, right. And so part of what I'm asking is, has anybody taken Prob and Stats 220? Right, and so if you've taken like the introductory stats course that you take as part of like a psychology psychology curriculum, or if you went to the liberal arts school I did, they required you to take it because I don't know why. Yeah, they will teach you about selection with replacement or selection without replacement. And so I have been fairly ambiguous in my gestures about, I got a red one. Does the red one go back into the bag, or do we throw it away? Okay, and so let's start with the easy half. It goes back into the bag. And so the bag, the contents of the bag never changes. Is that a question? Or is that just a...
I was thinking like if we take the same one,
Yep.
is it allowed to take the same color or?
Yeah. So I mean, suppose I'm a total great. So I'm allowed to be the biggest jerk ever, right? As part of the setup, I'm allowed to take one marble, color arbitrarily blue, and that's the only thing in the bag. Every time I call pick marble, you'd better return blue because that's the only thing in there. If we're doing it with replacement, right? I pull it out, I report blue, I put it back, I shake it up again, and I randomly pick the blue one again. Right, then yes, I'm going to pick the blue one multiple times. If we do it without replacement, where we pick it and we throw it away, then you better come back with an exception or an error or null or something. But for right now, we're doing it with replacement. Yeah.
Does it go like, for example, if it takes a marble and then you put it back, it goes to exactly the same position? And
It goes back into the bag, and the bag is opaque. Every time you pull a marble out, it should be a random event.
And randomness of the marble determined by random function, right? So index of the marble is random.
That's part of your job.
Okay. So if we don't have to update our data structure, we can choose like a static data structure. We need a function to update it, right? Update the length.
Right. Yeah. So pick marble can do whatever it needs to do statically with respect to the data structure.
Mm-hmm. And we take input randomly, or they like red, blue, blue, blue.
Well, if I can detect statistically that you're being non-random to within some percentage. I mean, if I put one red one in and one blue one in,
Mm-hmm.
there are universes in which I could shake up the bag and randomly pull red forever without ever pulling the blue.
Okay.
But at some point, I can say, look, you've pulled red 10 times in a row. No, I'm sorry, you pulled red 9 times in a row. There is a 1 in a million chance that you're actually random and you don't have a bug.
Okay.
And I can set my threshold wherever I like.
Okay.
Right? You know, how many times do you have to flip a coin before you go, you know, you may be cheating? Okay, so somebody propose a data structure, or I will propose the trap data structure, and then you can tell me why it's bad. Okay, one of the things to do when you're faced with a question like this and you're stumped, I mean, part of it is nobody wants to look dumb in front of the whole room, which is, you know, I get it. But one of the ways to answer these questions is, or one of the things to think about when I'm the interviewer is, you don't want to leave a whole lot of space blank. Candidate thought about problem for 3 minutes and was completely unable to come up with even the simplest answer. Maybe not where you want to go, okay? And so, if you're not seeing anything obvious, any obvious threads to pull on, start running your damn mouth about the stupid answer. Running your mouth about the stupid answer gives your subconscious a break, right? You've all been in the situation where you're trying to think of a word, you can't remember the word, and it's on the tip of your tongue and you can't get it, and the moment your attention changes onto something else, it pops in. Okay, so start running your damn mouth about, okay, I don't see the best answer yet, but a brute force approach would be, and you talk about the brute force for a minute and a half. Ding, and the light goes on, or it doesn't. But at least I know that you know the brute force approach, rather than you sat there for 5 minutes and you couldn't come up with a perfect answer and you go, I give up. Now, I'm 90% sure that 90% of you have some idea about how to attack this, you're just being shy. So in the name of heaven, somebody stick your hand up and be brave. And say, what data structure would you like?
I think I would use a hash set
Okay.
with a key and the number. I would, for each color given, I would give it a random key. Like not random, but like if it is red, it is initial 0. If it is blue, it is initial 2. And I think like when like picking the numbers for like the each key, I would increase its number if it is like taking.
I'm sorry, I get.
Oh, okay.
I thought you were going to fall exactly into the trap I wanted you to, and you're not. So just start from like 10 seconds back and tell me where you're going. So, A, am I right about this? You've got the key is the color and the count is the value is the number of normals.
Yeah, I just said that instead of red, I would like give it a number, but I think it's the same deal anyways.
Right. So some you knew. Okay. So, congratulations, you've fallen into the trap. Thank you very much for being the one to stick their hand up and be brave about it. So here's the trap. We've got this function, pick marble. Taking no parameters, and you've got this data structure. Okay, I'm going to be a jerk. Okay, I've called pick marble. Talk me through what your code will do. You've got some random function. Now what?
It will probably select blue.
Okay, well, what? This is going to return a number, all right? It can return a floating point or an int. Do you care?
I think.
Yeah.
Oh,
Sorry. I think you care for int.
Yeah.
You need int, right? 'Cause
Int,
you
okay.
map them
So
as
let's
int.
suppose this returns an int. Okay, what range do you want to return it in? Right, your total range here is, well, I mean, we can label that one 0 to make things all computer sciencey. So is your random range returning? So this is your total possible set of keys. 0, 1, and 2. You've got 10 marbles in the bag. You want a random integer between 0 and
2.
2. Okay. So now you've got a random number between 0 and 2, which implies a color. You've got your color. Suppose arbitrarily that we have picked green. Okay, so I have picked, I'm going to be a jerk and I'm going to say the color is currently equal to 2. Now what?
I think the solution that I will approach it with will be if the keys value is equal to 0, either increment it or decrement it.
Okay.
If the incrementation doesn't work,
Okay.
start decrementing it and try if there is a color for it.
Okay, so I'm slightly mixing syntax here, but I'm probably going to be mostly Python.
And like, while it wouldn't be random at the last part, since the first decision is random, it will be random, I guess.
Okay. So, okay, now if I add 1 to color, then it's outside the range of possible colors. And so now you're in trouble.
So towards there, I will put an if sign to see if the ranges will be like out of range when I increment it and
Okay.
start decreasing.
So you're about to dive down into a rabbit hole of what do we do if we're picking a color that doesn't even have colors, doesn't even have marbles at all, okay? And what I can do to simplify your life is, what you want to do is, in your init function, you want to arrange your world so that you get the total number of colors, right? And so rather than constants for these, you just say red. You'd have some mapping somewhere, but essentially you want to establish that I only have 2 colors rather than a total of 3 possible colors. And so now you can't make a mistake. Now you've picked a color where you've got marbles, right? Okay, great. So I arbitrarily pick 0 or 1. If I pick 0, then I come into, well, whatever I've got. If I pick 0, then I come into blue, and I report blue. And if I pick 1, I have red, and I report red. And my output is going to look like problems? The moment your interviewer asks you, is there a problem with that? 90% chance there's a problem. 10% chance they're doing a sanity check to make sure that you, in fact, are that sure and you weren't just guessing. If I think for a moment that you're guessing, I will try and ask you, are you sure about something that you are sure about or you should have been sure about? Okay. But there's a problem here. What percentage of blues are there in the bag?
9, 10.
This is about 50-50.
Yeah.
Yeah.
Okay, so that was the trap is, it's perfectly reasonable to do this. It looks easy. It's exactly the thing that I described in the setup. I'm giving you a key and number of things for that key. Of course you put it in a map. But putting in a map gets you this. You're going to be evenly distributed across the number of colors without any idea about how many marbles in each color. Okay. So that's one way to attack it. Somebody else, now that the ice has been broken, take the other obvious answer. Okay, something to think about, or something to know, maybe, about your interviewer. If I'm interviewing somebody straight out of college, I'm trying to do a few things. One, I can't afford to ask one big long question. If I ask one big long question, I am roughly speaking giving you a lotto scratcher, or rather I'm giving me a lotto scratcher. If I'm asking you something you just did last semester, you can tear that up for 45 minutes. If I ask you something you did sophomore year, and now this is the fall after your senior year, you might remember that, you might not. And you might be a genius, but if I ask you something that the last time you touched it was 2 years ago, you're not going to be great. I'm cheating myself. And so I need to ask a lot of little questions to give you, right, because the interview process, all I want is somebody who is really, really good at something. The fact that you're terrible at 18 other things doesn't matter. And I don't care what thing you're amazing at. Google has enough things to do that if you're amazing at this, we can find some place where amazing people can really make progress. The fact that you flub 1 or 2, fine. Okay? And so I will ask a bunch of little questions. This is a little question. With the idea that we're just trying to poke around to find some place where you can shine. Okay? The faster we can get through, I don't know, I can't do this one, the faster everybody's happy. Blowing 1, not a big deal. Okay. The other thing is, I don't want to assume a whole lot of prior knowledge. I want to assume that you know about if statements. You have to know about loops. You have to know about what a function is. If we're really going to get into it, I might give you a pre-existing class or a few classes and ask you to talk about what the relationship is or what the design is. But if I ask you to write a class from scratch, that's heading towards all 45 of my minutes, and that's heading towards, I just gave myself a lot of scratcher. Okay. And so part of the skill in attacking these questions is, okay, here's the horrible truth. I get 45 minutes with you, I'm gonna spend 15 minutes on a question. Doing 15-minute bite-sized questions is a skill. It has almost nothing to do with software. It's like solving puzzles. Go to Glassdoor.com or Topcoder or whatever. There's a million sites out there with questions just this size. Do 50 of them or 100 of them. After you've spent 2 weeks doing 50, when I interviewed at Google, I had 20 years of experience in the field, and I spent 30 hours of my own time doing dumb puzzle questions until I could knock a question this size down in 15 minutes. When I started, it took an hour. In the room, you want to take 15 minutes on this question, this one in particular. It's dumb, it's stupid, everybody hates it, and it is the best we can do. If there was anything better we could do, we would be doing it, trust me. And so, being able to attack this flavor of problem is a skill. Fortunately, it is a skill you can cram for. Right, you can, as I said, you know, in 2 weeks, 3 weeks, 4 weeks, you can cram for this skill. The only other skill you can cram for is leaving yourself enough room on the whiteboard, right? Because if you have to come back and fix something, right, trying to scribble in teeny tiny is no fun. I don't imagine people are doing interviews on whiteboards, so that's not much of a thing. Okay, so the dumbest possible data structures are map, dictionary, which we've just seen.
Array,
Array,
tree,
tree,
List.
list, and that's kind of it. Okay? And the last time I used a linked list was, I don't remember, it probably has to have been in the 2000s, but it was for a very specialized memory management application. Nobody uses lists anymore, right? Linked lists are, given the size and capacity of machines these days, nobody's using linked lists. Trees are not a thing. Trees are going to be a thing, but trees are not a thing for this part of the question. So somebody talk about how you'd represent this with an array.
So because we need a
Oh, no, hang on. Oh, I'm sorry. What? I wanted to get somebody I haven't yet before.
Maybe what if we like store an array of like fractions of the back?
Okay.
So like we have one array that has like, let's say we have 1 out of 10 red ones. Okay, 0.1. The next one maybe we do 2 out of 10, so we do 0.3. Or 9, yeah, point. Yeah. So maybe we say maybe 1.
Okay.
So you add like whatever's previous. I guess that doesn't matter too much. And then you would just kind of generate a random number between 0 and 1 and see like where you go.
Okay. And so what's the big O for space?
I guess number of colors.
Number of colors. And what's the big O for speed?
Also, why not just also number of colors, right?
Right. Number of colors over 2, but number of colors.
Okay, sure.
Yeah. And so depending on pernickettiness, right? It's any constant drops out, and so it's O number of colors. Okay. So that's one way to do it, and hang on to that thought. We're going to need it in the second half. Okay. There is a way to use an array and get O one time. Has anybody ever said space-speed trade-off to you? Okay. There is a way to waste space and get speed. What is the most wasteful thing you could possibly do for space? Somebody I haven't seen before. Back of the room.
Put every single marble in a array,
Every single one. Okay.
and then pull off the top. Oh, shuffle it first and then pull off the top.
Aha. Damn you. Okay. So not red, 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 green, 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 green. 3, 4. Okay, so not like that, but rather shuffle it at init time. and then you said
Yeah, pop it on.
pop. Right, cool. Okay. And so, yes but no. You've answered this. You've answered the second half of the first half of the question. So yes, shuffling it is a fantastic answer, but popping it is going to throw one away, and so now we're doing it without replacement. Okay. If we did it with replacement, you can just dump them in stupidly and randomly pick. Okay, and so that answer is better in the sense that if you just pick randomly, well, okay, so this is slightly bad in the sense that if you go pop, 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 and I'm asking for an implementation with replacement, you get to hear, and now what do you do? Right, there is an answer, but tell me.
Insert the max and then shuffle again.
Okay, so if you, so if you insert it, if you pop and then reinsert and reshuffle, what's your big O now?
Yeah, it's big.
Right. Okay, and so shuffle first and then pop on pick marble is great for without replacement. Dump them in stupidly and then randomly pick is good for without replacement. Okay. Curse you for having an excellent answer early. If you hadn't seen the pop thing, then there's one more trick that I want to put in your trick bag. And so normally what people do is they say, well, we just put them in, in order, red, 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 greens, and then all blues. We randomly pick one, and then we mark the ones that we picked. Right? And if you happen to fall on a space you've already picked, you just pick again. Okay, but if you do that, by the end of time, right, you're going to spend a lot of time randomly picking to get that last one. Okay, and so the way you do this to do pop without really having to do pop is you randomly select this one, and rather than marking this one as dead, what you do is you take this blue from the end, logically popping it off. Okay, so it's almost the same game, right? You're popping one off the end, but rather than really popping it, you just take the value and you put it down here, and then you don't have to pre-shuffle. Which one is better? I like the pre-shuffle one better because when you come back and read that code in 6 months, it's going to be a lot more clear what's going on. A little bit more.
Question.
Yeah.
Always from the end or randomly?
Well, okay, so I'm starting with, oops, hang on. Okay. So I start with this. I dumbly dump in all the red ones and then all the green ones and then all the blue ones. And because I didn't shuffle it first, I have to pick a random number here to get randomness. So I randomly pick this one. Okay. Having picked this one, I have to get rid of it if we're doing without replacement. Okay. There's 2 ways I can get rid of it. I can just mark it dead, but if I mark it dead, I'm going to wind up with a whole bunch of dead cells, and it's going to take forever to pick the last one. Okay, and so the way to deal with this, rather than marking it dead, is pop this one off the end and put it here, and you can do that in one time. And now you still get randomness without having to have done the shuffle in the first place.
Okay.
Is that better? Well, yes and no. How many shuffle calls am I going to make, or how many random calls am I going to make?
One for the thing and this one.
Right, so I'm going to make one random call for each marble.
Yes.
Okay. Guess what? Shuffle will also make one random call for each marble. Typically. Right. Typically you just start here and randomly swap this one with any other marble, and then you just walk the array, swap, 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 swap.
Mm-hmm.
Okay, so it's kind of 6 of one, half dozen the other on the big O. And so now it's just down to which code would you rather come back to and read in a year when you've completely forgotten what the hell you did. Okay. Anybody else? Questions, thoughts, comments? Okay. Okay, so second half of the question. Exactly the same question, but now we have up to 1 million different colors, and for any given color, we have 1 million different marbles. Okay, what's the trap here? There is a trap here. It might be a trap that's so obvious that it's not worth mentioning, but still there's kind of a trap. Okay, if somebody suggested, hey, let's see if this works. For whatever reason, black is always easier to erase than anything else. Will that fit in memory? How could you tell? Okay.
1 million?
Hmm?
1 million?
Well, so I promise. Okay. So possibly we've got up to 1 trillion marbles. Can anybody tell me how many bytes I'd have to use to represent each marble if we did it this way, right? We're going to need an Init value for each color.
Also, when we put like the marbles, we have some middle marbles, we put them in an array. And we have to have this exact same position of those marbles into the array. And it means like we have to copy each array and create one more in the size more, like this, or?
No, I'm proposing, just as a trap, I'm proposing doing exactly what we did before. And so we're only going to have, so the input that I'm going to pass in to init is going to be very compact, well, very compact, right? It's just going to be, right? So I'm going to have as compact as you can possibly get, just a dictionary of enum and how many marbles. And what I'm proposing doing is turning this into one big array of 7,834 reds, followed by 123 greens, followed by, etc. So there's not necessarily any array copying. There is if you're talking about some fairly subtle stuff about memory allocation and creation of arrays.
Mm-hmm.
Oh, okay, so that's what you are talking about.
Yeah.
Tell me. You win a prize. You're in the top 5%. Almost nobody ever talks to me about the internals and the subtleties of how their data structures work under the covers. They think an array just always works. Talk about reallocation on array resize.
So I was saying, like, if we're gonna allocate so many array elements, decide how many bytes will it require and how many energy of the computer will have it. So it will be implemented, right? And then we have to every time to implement it one more time and copy it and paste it again until we have this million.
Okay, so I think you're exactly on the right track. But in general, this is a problem I have as an interviewer. I'm going to keep poking at you because I'm 90% sure that you know exactly what you're doing, but I haven't exactly heard the words that would prove it. So I'm going to poke again. Please don't take it as I'm poking at you. You're talking about you have to reallocate,
Yeah.
and copy. When does that happen?
when we're gonna place them, like we ask the user, for example, to enter the arrays, to enter the marbles itself, and then we have to put them into the array, right? In the moment of the allocation.
Okay, so let me walk through and see if I can read back what you're saying, because I'm still not 100% sure. So I start out, I say, my marbles equal some empty array. And then I say,
And then the array is static, right?
the array is, yeah, so I'm never going to change my mind about what n is. So the Python code looks like, oops, provide in range num. Okay, is that legible as pseudocode for everybody? If anybody is having any trouble with this at all,
can you write the top 2 lines again?
Sure.
You cannot see.
okay, so in Python, if you say dot items over a map, that'll result in 2 tuples, and it'll give you the key and the value, and it'll unpack that into the key and the value. And then I say for, okay. Okay, and so this is a generator that will generate every number from 0 up to num. And it doesn't even matter what this is. I can, the Python usualism is you use an underscore to say I don't care what the name of this variable is. All I want is a loop that operates for the number of times this color occurs. And then I append to my array m the color. So if I had 325, right, I'd iterate 3 times here and put in red, red, red. I'd iterate 2 times, put in green. I'd iterate 4 times, blue, 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 blue. Okay, so now m is that. Okay, and so you were saying something about arraying and copying.
Yeah.
Okay, when does the copy happen?
So I was thinking like when we put more stuff in the array itself, right? How we gonna keep like maybe not even the same positions of the marbles itself, but like how we gonna allocate one more array that is bigger for one.
Right, okay. And so the question is, what the hell is happening under the covers here? Okay, I just said I wanted an empty array. Any reasonable library would say, okay, you want an array of size 0, congratulations, I will allocate you an array of 0 bytes. No, that's insane, right? You allocate an array and you say, nobody in their right mind, we're gonna allocate 100 units. Why 100? Well, 0 is crazy, nobody can do anything with 0. The moment they do anything with the array, we'll have to reallocate anyway. And 100 is not that big in the grand scheme of things. We'll allocate 100 things, and that's it. And then as you add, you get to a point where 100 isn't enough. What do you allocate now? Well, you allocate, and typically you double. And so you allocate 200, and then you copy everything over. And then you allocate 400 and copy everything over, and you copy 800, and if every time you double, you wind up paying less and less and less often. And so, technically speaking, come and grab me after, and we can have an extended discussion. But the fact that you double every time is why maps, dictionaries, are allowed to claim their amortized constant time on insert rather than constant time. It is in fact amortized constant time, but the constant is very large, or large-ish. And if you didn't know that, then knowing a little something about what's going on under the covers in the data structures that you use and the real-world consequences is worth something in an interview. It's worth bonus points. It's worth me saying, oh, aha, this person is a little bit above average. I'm going to give them the benefit of the doubt in one other situation, maybe. Okay? So yeah, just sticking them in an array is dumb from a couple points of view. One, okay, so let's come back to this. If I have a million colors, I have to have at least a million different numbers to represent these as a union, right? Okay, how many numbers can 1 byte represent? I heard it. 256?
Yeah.
Great. How many bytes, how many different values can 2 bytes represent?
5.
512. No. So what you do is every bit you add, you can multiply by 2. Right? So 1 bit can represent 2 numbers, 0 and 1. 2 bits can represent 4 numbers, 0, 1, 1, 0, 0, 0, 1, 1. 3 bits can represent 8 numbers, da 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 da. 8 bits can represent 256. 16 bits can represent 65,536. Not that anybody cares. Okay, 65,000 is smaller than a million, and so technically, 3 bytes is enough. But there are no 3-byte data structures. There's no such thing as a 3-byte int. Right? All you've got is a 4-byte int, or typically an 8-byte int. Okay, and so if you're going to have to represent 10 to the 12th marbles, you're going to have to you're almost certainly going to need 4 times 10 to the 12 bytes, or maybe 8 times 10 to the 12 bytes, depending. And so either that's 4 terabytes or 8 terabytes. Anybody have a machine with 4 terabytes or 8 terabytes? You can get them. They still cost, okay? And so storing it in this array is bonkers. Okay, so so now we are in a world where we no longer can trade off space for speed. Now what? And let me commend to your attention the previous answer. Where you just pick a random number between 0 and 1, and you walk across accumulating. If I pick, I say, is this smaller? Yes. Okay, I take that and I add it to my running total. Is this smaller? Yes. And I take it and I add it to my running total. Is this smaller? Yes. I take it, okay, which is fine, but that's O number of colors. There is a way to do this in O log of number of colors. Yeah, no, you, sorry.
Binary search, yeah,
Great.
sorted and binary.
You binary search.
Okay.
How do you binary search? These numbers are not in order.
Sort the colors, yeah, sort the series of colors.
Kind of. Okay, so let me do that. You know what that might actually work?
Or
Oh, no, I'm sorry.
you can like add, like cumulatively
There you
add,
go.
like a prefix sum, I guess.
Right. And so rather than 0.153, it's the number of the proportion of marbles in this color plus all the colors to the left. Right, and now you have a strictly increasing set of numbers, and you can, and as you say, you can just binary search in here. Hooray. And so now that gets you to one of these spots. And if we're doing it with replacement, you win. We're done. If we're doing it without replacement, now what?
So I think one thing I would definitely mention if I was doing the interview is floating point precision is like really important, and especially with a million colors and things like that, it gets really bad. So I definitely use whole numbers and then decrement, but changing a whole lot of values is also pretty different. So if you have to use like a pretty complex structure like a segment tree or something, but
Right, okay, so let me talk about those two things in two different halves. One, literally like 6 weeks ago, I got bitten directly in my backside by this. Blah, 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 blah. We allocated IDs into our database. I had to change things suddenly because emergency, because reasons. And I was, rather than letting the database do its own ID allocation, I said, great, I will just pick a random number between 128-bit random number. Great. And that's UUID 4. If you pick a UUID 4, you get, it reserves 2 bits for the fact that it's UUID 4, and you get 126 bits of randomness, of entropy. 126 bits of entropy, even if you do 1 billion things a second for 70 years, your odds of getting a collision are 50-50. Anybody know the birthday paradox? Okay, so here's the deal. We have something like 30 people in this room. 23 is the number. Let's do it. Birthday. Not the year, just the month and day.
You mean the month?
Month and day, birthday.
3rd of May.
May 3rd.
May 1st.
August 29th. Oh, October 20th.
July 21st.
July 31st?
21st. December 27th.
December 25th.
November 4th.
October 11th.
March 4th.
March 1st.
Series of December. December series.
May 29th.
Getting close.
June 22.
March 20th.
June 8th. June 8th.
But if you have 23 people in a room, it is 50-50 odds that you get a collision. Right, with 30 people in the room, it's damn near certain. Okay, so that's birthday paradox. And so if you pick numbers at complete random and you throw them in a database as IDs, if you ever get 2 IDs picked at random that are the same, and you just stomp one record over the top of the other, you're going to corrupt your data. But if you pick up to 126 bits, the odds of ever getting that collision is basically 0. It's as close to 0 as makes no difference at all. And so I write that up and I check it in, or I try to check it in, and it doesn't work because the tests don't pass, because the biggest ID the database allows is 64 bits. Okay, and so I do the work and I pick a random number in 64 bits, and then I have to do some work to make sure that that number is unique. I do the work to make sure the number is unique. I run the tests. The back-end tests pass. The front-end tests fail. And it turns out that we generate an ID number that's pretty big. We hand it up to the front end, which is written in JavaScript. And it turns out, dear hearts, that JavaScript represents every single number ever. Integer, floating point, anytime you tell JavaScript this is a number, it will think it's equal. If it's an integer, it remembers it's an integer, it displays it as an integer, but it stores it in an IEEE 64-bit floating point number. And an IEEE 64-bit floating point number is 1 bit for sign, 10 bits for mantissa, meaning what power is this number raised to? And then 53 bits for the actual value. And this is just a standard integer. Right? Some integer in binary representation, and then this is the power that that's raised to in terms of powers of 2. And so as long as your number fits within 53 bits, then that number is exactly representable in JavaScript, and if it's not, it is not necessarily exactly representable. So whoever said that, excellent catch. And yeah, the other half is, so if I pick one out of here, I have to change my odds very, very slightly. And I have to change the odds all the way down, because remember, this is the running sum of all of these. And so the moment you do without replacement here, you are now big O number of colors again. And the cute way to do it is, in fact, with a tree. And I will let you go look it up on the inner tubes. Okay, that's that for that question. Let me do 10 minutes on coding question. And then you are free to do whatever you want. Stay here and ask me questions or not, as you please. Okay, so here's my standard coding question. We have a graph. The graph has edges. And what I want to do is find the minimum spanning tree of that graph. And by minimum spanning tree, I mean if each of these edges have weights, whatever the weights are, I want to find the set of edges that connects every node but has the least weight. Okay? And one of the ways to do that is, at the beginning of time, consider each node to be in its own group. All right, so this is a group, 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 this is a group. For each edge in increasing order by weight. And so if this is 1, 2, 2, 3, 4, 5, 6, 7. If edge connects two different groups. Edges in the node spanning tree, and you merge the groups. So a slightly easier example. A, B, C, D, weight of 1, weight of 2, weight of 3, weight of 4, weight of 5, weight of 6. Okay? And so you begin with every node that is in its own group. You start with the edge with the lowest weight. This is the lowest edge weight. AB. A is in its own group, B is in its own group. Those are different groups. AB is in the interesting step. And those are one group now. CD is the next highest weight. CD is an interesting select because it spans two different groups. You merge the groups. Next edge is AC. A and C are in different groups. You merge the groups. Next edge is BD. B and D are already in the same group, so you ignore it. Right, same thing for the rest. I like this one because it's fast to explain in English and it gives you no help at all about what the code is. Okay. The way to attack a coding question is think about the problem. I know this is hard. I know everybody wants to look like a genius. I know you want to get the bestest answer possible. But in the name of all that is your job on the line, talk out loud. Talk out loud. Think about what's going on and run your damn mouth. I want to hear you think out loud. I want to hear how you think. I want to hear what mistakes you make. I want to hear what holes you fall into. I want to see you climb out of those holes. I don't want a perfect answer. I want to see how you approach the problem. Spend as long as it takes until you understand what the hell is going on. If that's a long time, that's a long time. The problem is, if you say, okay, I basically understand it, I'm going to start coding. And you get here, and you say, oh shit, I have a design problem. Like 5 million extra points. You recognized while you were writing code, as you were writing your code, you still had enough processor left to think about the design, recognize you had a problem, and go, oh shit, and pull the ripcord. Fantastic. Good job. And then you go back and you do it again. Right? The problem is that getting a bajillion extra points for seeing a design problem while you were writing code is not going to buy you back the 10 minutes it took to write the first version badly. That's 10 minutes I could have used to find something else out about you that was amazing. So there's nothing wrong with getting to, oh shit, and correcting yourself. You have to. But if you possibly can, try and find all the traps in here before you start coding. Okay? Then write your code. Once you've written the code, I want you to consider what happens if you get 0 edges. Right? Always consider the trivial null case. What if your function is given effectively empty input? Does your function break or does it return the right thing? Many mentions. Does it work in the does it work in the trivial case? Right. 2 edges. And then worry about what happens if you get a bajillion of these. Is anything in here n cubed? If anything in here is n squared, at least remark on the fact that yes, this is n squared. And if you can't think of a way to make it O n log n or O n, say so. If you can see a way to make it n log n, but you're not quite sure how to do it, say so. It is far better that I write down, candidate was able to get the brute force solution in 10 minutes flat, could see that there existed a better solution for n log n, but we didn't want to spend 20 minutes working it out when we could have spent that 20 minutes more productively on something else. Right? If you're sure you can get to the n log n in 5, spend that 5 minutes there. If you're thinking, well, there's 20 minutes, maybe not. Now, part of my job as an interviewer is to manage the time. If I let you run with this for 20 more minutes, I'm gambling that you're going to get there. From the point of view of, did I get to say, person was amazing, person found the best answer ever. It took all 45 minutes, but man, were they good. Well, okay, you win. But as an interviewer, it is my job to hand you to the next interviewer in a good state. If I let you get halfway through solving a hard problem, and then I say, I'm very sorry, our time is up, I need to be respectful of the next person's time, we have to cut it off here. I can see where you're going, I can see you're gonna finish. You just haven't finished the code, but I can see you have all the right ideas. That's okay, but I have just put you in the hands of the next interviewer with 20% of your brain occupied with finishing my question. I don't want to do that. It's hateful, it's awful, it's not fair to you, it's not fair to the next person. And so if somebody says something like, I can see that you're going to finish from here, I can see that you have all the right ideas, I do want to stop here and take the next 20 minutes to do something completely different. Let them. Right, I'm trying to hand you off to the next person with an empty brain. Okay, as usual, I am bitterly over time, and so feel free to wander out whenever you like, or feel free to stand here and ask questions for as long as I can stand and as long as you maintain attention and interest in me. Your call. That's my email address. Feel free to ask me anything useful you'd like to ask. I'm not going to help you with your homework, but if you have career questions, by all means.
Thank you.